All right, so starting with our first problem. So here are the parameter changes. Whenever something happens to the size and shape of the function, we call that a parameter change. And that includes stretching, shrinking, and you can flip or reflect your graphs, and we'll learn about that today. So first we're gonna graph y equals 2 to the x power. So we're going to use that same XY chart. Who remembers what that was?
-2, -2.
Okay, so then we plug those numbers in. So for -2, you should get 0.25, and -1 was 1/2 or 0.5. 0 is 1. 1 is 2, and 2 is 4. And then we're going to graph it. Okay, so on the next problem, what do you notice is different? Like, what's the same? What are you sharing with the problem before?
Yeah.
The 2 to the x power is the same. So now it's telling us to take that times 3. So we really don't have to put everything back in our calculator. We can look at our XY chart from the problem before and take that, all those values times 3. So our XY chart from before, -2 was 0.25, so we would just take that times 3. 0.75. -1 was 1/2, so we would now have 1.5. 0 was 1, so we now have 3. 1 was 2, so now we have 6, and then 2 was 4, so now it is 12. So the last one you're gonna not really be able to graph because it's way off of your paper. But you can just go up until 1,6. Okay, so we're gonna add in the parameter change, and we're gonna add in domain and range. So refresh your memory a little bit. Does anybody remember what domain and range stand for? Like, what do they mean? Anybody remember? What is domain representing? X, and range represents Y. So for the domain, you're looking at what values does it touch going from left to right on your X values? Does it ever stop? No. So it touches every number going left to right forever. So our domain would be what's called all real numbers. I think we've used this symbol before where it's like a double R. So since it touches everything, our domain is all real numbers. Okay, so our range, does our range touch every number vertically? Or does it cut off at a certain point?
No, it's can it not go to 0 or?
Yeah,
something?
so it's not going to 0 or lower, right? So we're gonna say that our range is positive, all real numbers. Because our range is not going from 0 down, like it's only above 0.
But if it continues, when you go past it?
It's never gonna touch 0, just goes forever. Okay, so the other thing that happened here was we took everything times 3. And if you look at this line compared to the one before, it got a lot more like steeper or more narrow. So this is what's called a vertical stretch, is what you actually call that. So when you're gonna multiply your whole entire graph by a number larger than 1, you're creating what's called a vertical stretch. And that makes it look more narrow. Okay, so I think this is on your notes outline, but this is an example of those two graphs put right beside each other. So notice that the 2 to the x power is wider than the 3 to the 2 to the x power. It's more narrow and it gets steeper. So that's an example of what a vertical shrink looks like. A vertical stretch, not a shrink. Okay, so now we're gonna take the same XY chart we started with number 1, and now we're taking it times 1/3, which is the same as doing what? Dividing by 3. So you're probably not gonna have the greatest decimals here, but what is 0.25 divided by 3? 0.8 something?
0.08.
So we'll just call it 0.08 and not worry about the extra. And then half divided by 3. And then 0 would be, we'll just say it's 0.33. 1 would be 2 divided by 3, so 0.6. And then 4 divided by 3, so 1.3. And again, you just have to do your best with graphing your decimals. If I were to put a 3 in there, so 2 to the 3rd power would be 8, and then 1/3 of 8 would be what?
So you want us to add another one?
Yeah, I added another one so I could help draw my curve a little more accurately. Okay, so then we're also gonna do domain and range again. So for domain, that's your x values. Is there an x that won't eventually be touched on the graph? No, it's all real numbers. And then for the range, what are we stopping at? 0, so it's positive, all real numbers. Okay, so then taking it times 1/3 or dividing it by 3, that created what's called a vertical shrink. And when you have a vertical shrink, your graph is going to get wider. And you get a vertical shrink when you take your graph and multiply it by something less than 1. Whether it's a decimal or a fraction, it's still less than 1. Okay, so this is those two graphs side by side. So notice the graph got wider and it's not as steep because we multiplied it by 1/3. Okay, so now let's look at -2 to the x power. So we're still using that same XY chart, except this time we're gonna make all of our y values negative. So -0.5. Okay, so this time, when we look at our domain and range, so what is being, what's on the X value there? On domain? Yeah, all real numbers, it touches everything, but then on the range, it goes, negative numbers up to 0, but doesn't touch 0, so negative all real numbers this time, because we are pointing into the negative. And then what happened here, whenever you have a negative in front, we created what was called a reflection. Now, did this reflect across the x-axis or the y-axis? Correct, reflection over x-axis. Okay, so this is an example of what that looked like. Like when the two graphs are the same. So it reflected across the x-axis, but other than that, it's exactly the same. Okay, so now we're going to start, so when you see this where it says compare, okay, you're looking for those parameter changes. So it can be a reflection, it can be a vertical stretch, or a vertical shrink.
Well, how do you know which one to compare to which? Like,
So you're comparing that graph to this graph right here. So it is helpful if you graph both of them, unless you're able to tell what it's doing without graphing both of them. So if you look at like your number in front, which is 1/2. So based on your problems before, if you take something times 1/2, which change is happening?
shrinking, so wouldn't it be a stretch though? Because the other one is bigger than that. Yeah.
No, so this number in front, this 1/2 being less than 1, automatically makes it a vertical shrink.
But compared to that
Compared to that one, like that one,
that
if you
one
think about it, that one
compared to
just
that one
y
is
to the 1 times 5 to the x. And so 1 is bigger than 1/2, so.
Well, you're
Like this
Stretch.
one's small, but compared to that one.
Well,
You
it's
could
still a
probably
vertical
do
shrink because this
it.
one's gonna get wider.
The shrink is only.
Yeah, but the wider one,
and then narrow, that makes more sense.
It does,
Doesn't
but
make sense.
it makes, I guess if you think of it like if you get wider, the graph isn't getting tall as fast, so that's why it's a vertical shrink. But this is a vertical shrink.
But if you're
Oh,
starting with
that
vertical.
No,
if you
you're not,
start
you're
with
starting with the
shrink
other one
and
because you're comparing
You're
the first
starting
one.
with this. This is your parent, what's called your parent graph,
Oh.
the starter graph.
Can we just write shrink across the neck?
Vertical shrink? Yes, this is a vertical shrink.
So if you have one with a negative, what would it be? Shrink.
A reflection. Okay, so this is 1/5 times 5 to the x power. So if I use those same numbers, okay, so I'm taking 5 to the -2 power first, and then taking 1/5 of that. Did anybody get that all right? I got 0.02.
Oh, okay.
Wait.
You said 1/5.
Oh, it's 1/2, I'm sorry, 1/2. So then for -1, you're taking 5 to the -1 power first, and then dividing in half. So I got 0.1. And then 0.5. And I got 2.5. And 12.5. Okay, so then I'm gonna graph that. Okay, so this is the other thing we need to pay attention to. On this graph, the scale is going up by 5s. So my numbers are basically gonna look like they're right at 0. Okay, so I'm gonna add one more on here so I can know I can make my curve a little more accurate. So let's add in 3. So 5 to the 3rd power and then 1/5 of that, which I believe would be 125, not 1/5, 1/2. So 5 to the third power,
52.5.
which is gonna be pretty close off our chart. So that tells me that this is going like way up here. Okay, so this is, even though it looks like it's really narrow, this is technically a vertical shrink. And then we need to also do the domain and range. So for the domain, what would it equal? All row
All row
numbers,
numbers are next
and
to
then the
that.
range, what's the range? Positive, all real numbers. Okay. I want to kind of skip through a couple. So if we look at just this one, we're not going to graph it, but what parameter change happened? Vertical stretch. And if you had to guess, what do you think your domain and range would be?
Oh,
All real numbers and then positive, because there was no negative involved. So that would be our domain and range. And I can tell all of that without graphing. Okay, so if I look at the next one, we're gonna actually do this one. So I am going to use that same XY chart. And we are taking like 4 to the -2 power and then take it times the -2. Okay, so what would you end up getting for -2?
0.125. Negative.
Yep. And then for 1, I got -0.25. Did anybody else get -0.25? Or did I get? Did anybody else get the answer for -1?
I got -0.5.
That's right. Okay. And then for 0, -2, 1, -8, and 2 is -32. So that one's gonna be off our chart. Okay, so we have a couple different parameter changes that happen. So it is possible to have 2 parameter changes. Later on, we'll learn more than that. But, so what happened here that you can tell? What did the negative do? It caused a reflection over the x-axis. Okay, and then what would the multiplying by 2 do to it?
Vertical stretch.
Yes. So that caused a vertical stretch. So you can have a reflection with a vertical stretch and you can have a reflection with a vertical shrink. However, you cannot have a vertical shrink and a vertical stretch happening in the same equation. That doesn't make sense, right? That would be like pulling it and pushing it back together and all that. So you can either have a reflection and a shrink, a reflection and a stretch, but you can't have the stretch and shrink. Those can't be two options that go together. Okay, so for the domain, we have all real numbers, and for the range, we're in the negative, so negative all real numbers.
Is the domain always all real numbers?
In this generally, yes. Yeah. Okay, so without graphing this, what would my parameter changes be? Reflection over the x-axis, and what would the 2/3 do? Vertical shrink, okay? So here, so this one's kind of tricky because the 1/4 in the problem is a fraction. However, that doesn't make it a shrink. You're looking at the 3 in front of it. So what is the 3 in front of it gonna do? Stretch it. Okay, so you have a homework sheet with graph paper.